Hi chemists, today is June 1st and we are starting Unit 6. So I'm going to share my screen. So Unit 6 is going to be similar to the revision bundles in how it looks, but it's just kind of a step-by-step to get to this goal of our mini QPA 1 and then our QPA for a separate document. So you're going to have 2 of these to complete for Unit 6. So for Unit 6 in chemistry, I need to update this. So we're working on solutions and COVID-19. So not solutions in that, like a way to solve a problem, but solutions in that it's a mixture, a homogeneous mixture, meaning homogeneous meaning all the same, coming from the word homo, meaning the same. So a mixture that's the same all throughout it. So for example, water is homogeneous. Like that one sip of water should be exactly the same as the rest of it. It's all the same. There's no separate layers. Whereas a good example is like chocolate chip cookies. That's a heterogeneous mixture because you can very clearly see that there's the cookie dough batter itself and then chocolate chip cookies in it that make it two separate things. They don't blend together and mix in the same way that the homogeneous mixtures do. So in this unit, we are going to examine solutions and how ionic substances dissolve into polar substances. So this is a big throwback. So remember, ionic substances are typically going to be a metal and a non-metal, and they bond together just by attracting each other. They don't actually, like it's a transfer of ions, so a transfer of electrons, meaning that one is going to be positively charged because it gave up an electron, and then the other one's going to be negatively charged because it gained an electron, and then they're just going to attract each other because we know that opposites attract. And how these ionic substances dissolve into polar substances. And polar substances meaning what again? This is again a throwback. So polar substances meaning that there's an unequal sharing of electrons. So one atom wants the electrons more. So for example, in water, we have this. Let me show you, annotate. So we have water, we have our H2O, which is commonly known as water. And then these little dots are representing electrons. So we see here that the oxygen wants these electrons more. It's more electronegative, meaning that it is going to pull those electrons more to itself that it's sharing with the hydrogen than the hydrogen can take, because oxygen is much more electronegative than hydrogen. And also remember, we talked about if there was this sense of symmetry. So we would draw our line. Okay, so it's symmetrical this way, but if we draw our line this way, it's not symmetrical, right? So we know that it's going to be a polar molecule because there's no symmetry to kind of balance out what's going on. And that they're not the same molecule, they have different electronegativities. So with that in mind, we are going to be looking at how these solutions relate to something that's very prevalent in the world right now. So COVID, coronavirus, COVID-19. We are going to look and see, apply this knowledge that we're going to gain about solutions to COVID. And our, specifically, we're going to think about washing our hands and hand sanitizer, because that's something that we're all being told, like, oh, we need to make sure we're using soap and water and hand sanitizer. That's going to help, like, make sure that we're clean and make sure that we don't get COVID. So we're going to talk about solutions in the context of COVID-19. So by doing this, you're watching our video bundle here. You're going to go over all these steps. So we have a PowerPoint for you to use. So it's talking about what are solutions, what are solutions, what are polar molecules, what is a solution made up of. So we have a solute versus a solvent, and it tells you all about that. So you go through this and then you watch this video on the dissociation of a salt. So this is what's happening when a salt, such as sodium chloride, so ionic substances, a salt, they're kind of interchangeable. Salt and ionic substances are the same thing. And so when it dissolves in water. So typically we're going to see that our solvent, which is usually like the liquid in our solutions, what happens when ionic substances are put into that liquid that's going to dissolve it. And then you go over what are ionic compounds. So you go through this page while filling out the corresponding worksheet. So look through this lesson. So we're using FAT. That should look familiar. We use that a lot during the school year. So talking about what ionic compounds are. So again, with these electrostatic forces, and then you have some practice here to determine what is a compound. And then here we have a demonstration, which unfortunately I can't perform a demonstration for you guys. But just given the data and what's going on here with the conductivity, and remember conductivity means how well it's producing electricity. You should be able to tell me if, like, what kind of substances these would be. So then we also have a simulation here, salts and solutions, and then you're completing the corresponding worksheet. So go on here, make sure that you play this, and yeah, it's a fun little game about how salts and solutions, what that means, how adding more concentration, more what it does. Finally, you're going to read about soap and COVID-19. So why is soap this magic thing that we need to be using to fight against the coronavirus? And then how soap is made. And then make sure that you are taking your own notes on what is soap made of and how is it a solution. So tell me, justify how it's a solution, and then how it prevents coronavirus. So what is soap doing that's so important? And then finally, we're going to work on our mini QPA. You click here, make a copy of it, and it looks like this. So you are going to read this article on why hand washing is more effective than hand sanitizer. So that is two things that I told you to be thinking about. So solutions, so thinking about hand soap, like liquid soap, and then hand sanitizer, and you are going to read about that. And then from this, you're going to write a reflection on, that must be at least one paragraph, on why hand washing is more effective than hand sanitizer. Be sure to focus on the chemistry behind it. So what are the solutions? What's the solute? What's the solvent? The ionic compounds, etc. So you have the space to write it, and then obviously your rubric. Please let me know if you guys have any questions at all. Good luck.